Alright guys, so this is a breakdown of Miss Edge reviewing the formative. So you should have picked up your formatives when you came into class today. Alright, so this is going to tell you where you went wrong or what specifically I'm looking at. So let's look at number 1. So number 1's video is a video of Mrs. Clausen just simply breaking a windshield. Okay, so the windshield itself does not change. Okay, she may hit it, but it's just in smaller pieces. Okay, due to the fact that it's the same substance, it's going to be a physical change. Okay, the windshield just breaks. All right, it's only a change in physical properties. Okay, so a lot of students here wanted to give me an observation of she broke the windshield. Okay, that's not justification why it's a physical change. Okay, it's a physical change because the substance, right, is still itself. And it was only a change to a physical property. Okay, so I was looking for something along the lines of that. It's still the substance itself, it's just in smaller pieces. Okay, if you just told me the windshield is in smaller pieces, all right, you need to tell me that it was still a windshield, still the windshield, okay? So number 2 really tripped a lot of students up. All right, so a student has a hand warmer, and the hand warmer combines iron with oxygen to produce iron oxide. Okay, a lot of you wanted to tell me that oxygen was produced. It wasn't. It starts the reaction. Okay, so it can't be made if it's in the beginning. Okay, warming a student's hand. Decide if this is a chemical change or a physical change. Okay, warming the student's hand is the big thing. Okay, if you've ever had hand warmers, you just kind of like crack them, shake them up, and they turn warm. Okay, so that's going to be a chemical change. Okay, because we're not adding any substances. The reaction is creating heat. So it's a change in temperature. Okay, as our justification. All right, it's because heat was produced. Okay, and we're not putting it in a hot plate. We're not adding anything like that. All right, so it's a chemical change. And how we know it was a chemical change is because of that heat production, okay? It doesn't say anything about the other 6 signs. Again, oxygen is used to start it. It is not produced, okay? Number 3 says water evaporates and condenses on the side of a glass of iced tea. Decide if it's a chemical change. So when it evaporates, it means it's going from a liquid to a gas. When it condenses, it's going from a gas back to a liquid, okay? So this one is a physical change. And I was looking for something like it's still water, even though it's in gas, it's back to liquid. But really all you needed to write is that was just a phase change. All right, it's just a phase change. It's still water, it just goes from a liquid to a gas back to a liquid. All right, video number 2. Okay, this one we did pretty good on. However, we had a bad habit of only using one. Okay, so if you look here and we slowed down the pour on the video itself when we did it, all right, yes, there is a color change, but you can now no longer see through it, and I made sure to pause as you watched it fall. Okay, that's a precipitate being formed. So this was 2. Okay, so not only was, we could tell it's a chemical change, okay, all right, there's 2 pieces of evidence, and you had to get both. There was a color change, all right, we had that nice bright yellow made, plus a formation of a precipitate. All right, and I was pretty nice with the spelling. And you guys really should have known this one because we actually did this one as a demo. Okay, all right. Okay, so color change and the formation of a precipitate is what you need both for number 4. Number 5, I went over this so many times as we talked about what is a physical and a chemical change. Some of us still got this wrong, okay? We start with a blue color, okay? Blue food coloring in water. A lot of you wanted to tell me that this was a chemical change, okay? We start with a blue color, we end with a blue color, okay? It's not color change if you start with the color, okay? This was a physical change, okay? It just simply is a change in physical properties. Food coloring just dissolves, okay? So I was looking for something like no color change. I accept it here, Okay, because it showed to me that you knew it was physical because it wasn't a color change. Same substances. Okay. All right. I was looking for just anything that showed to me that you knew it wasn't a color change for a chemical change, that you knew that it just dissolved. Okay, that one tripped a lot of people up. That we went over it quite a bit in class. So next time, make sure we're paying attention to those examples. Not everyone got tripped up though. All right, last but not least, this one, some of us got really, really well. Some of us were really confused. I got a lot of color change. Okay, guys, it starts as a white powder. All right, we got to make sure we know that it can't be a color change if we start with the color. Okay, nothing changed. So vinegar and baking soda actually generates, okay, you see that bubbling there? Okay, that means we made a gas, okay? And the reason to see the color, the candle, is because CO2 is produced, and CO2 actually puts out flames. It's not flammable. So the main thing that you need to take away from this, yes, it is a chemical change. All right, we see all that bubbling, and we should see bubbles and go automatically, oh, production of a gas, okay? I did not take the fact, if you just told me it bubbled, I did not accept that. And the reason why is because that's just an observation, that's not a justification. So this is a chemical change because gas is produced. Okay, again, if you just told me it got bubbly, I did not accept that because, all right, getting bubbly, oops, is an observation, not a justification. All right, if you got any questions, make sure you email me. Make sure you're working on your study guides today.